You know that feeling when you're clicking around a website and it just magically knows who you are? You log in just once, and then, boom, you have this all-access pass. You can jump from page to page and you never have to type your password in again. It feels seamless, almost like magic, right? Well, it's not magic. It's all thanks to a really clever piece of tech.
So what's the secret sauce? How does a server possibly keep track of you in the huge, chaotic world of the internet, where every click is technically a fresh start? The answer is something you and I use hundreds, maybe thousands of times a day without even noticing.
And here it is. Meet the JSON Web Token, or JWT for short. You can think of it as the hero of our story today. A JWT is basically a standard way for two parties, let's say your web browser and a website server, to securely pass information back and forth. Honestly, the best way to picture it is as your own personal digital passport. It's small, it's self-contained, and it tells the server everything it needs to know about who you are and what you're allowed to see.
Okay, so to really understand how these digital passports work, and more importantly how they can sometimes fail, we need to pop the hood. Let's take a look at the anatomy of a token and break this thing down piece by piece.
So, at first glance, a JWT just looks like a big, messy jumble of letters and numbers. But it's not random at all. If you look really close, you'll see two tiny dots in there, and those dots are super important because they split this whole string into three very distinct parts. Each one has a critical job to do. The first part is the header. Think of this as the cover of your passport. It lays out the rules, like what kind of security algorithm is being used. Then comes the payload. This is the good stuff, the actual information page with your details. It contains the claims, things like your user ID. And finally, and this is the most important part for security, you have the signature. This is the tamper-proof seal, the cryptographic lock. It's made using the header, the payload, and a secret key that only the server knows. This signature is what proves the passport is real and that nobody's messed with it.
Now, in theory, that signature makes a JWT rock solid. But in the real world, a system is only as secure as the way it's put together. And that brings us to a really fascinating real-world investigation we're calling the hunt for flaws.
So, picture this. It's May 2022, and 4 MIT students, Jamie Fu, Catherine Liu, Richard Liu, and Anna Wang, get curious. They decided to investigate an app they use every single day, their university's own COVID pass system. They wanted to see, how are their digital passports being handled?
And what they found was, well, it was pretty eye-opening. On the surface, the app looked great, clean, professional, totally legit. But then they popped open their browser's developer tools to peek behind the curtain. And what did they find? Their JWT. Their entire digital passport was just sitting right there in the browser's local storage. Think of local storage as a simple, unlocked filing cabinet that the browser uses. The passport was just left out in the open for anyone to find.
So, this begs the question, what exactly was written on this passport that was left out for all to see? Let's take a look inside the COVID pass.
So, what's the big deal? Well, the information inside that token was only base64 encoded, which, that's not real encryption. It's more like a substitution cipher a kid would use. It's trivial to decode. As the students themselves put it in their report, and I'm quoting here, it is entirely exposed to anybody who sees this token. It's like writing all your personal passport details on a postcard and mailing it, instead of keeping it in a locked safe.
And here's what that decoded postcard looked like. I mean, look at this. They didn't need any elite hacking skills. They just used a free online tool to decode it. And right there, plain as day, was the student's unique ID number, labeled Custom Employee ID. Now, at a place like MIT, that ID number is powerful. It can get you into dining halls, let you check out library books. It's a big deal.
And with that one stolen token, an attacker basically had the keys to the kingdom. If they just took that token and reused it, they could tap into the app's backend and pull all sorts of stuff. They could see a user's detailed vaccine status, complete with photo proof. They could falsely report symptoms for someone else. They could find out which dorm a student lived in. And maybe the most shocking of all, they could get the student's permanent 6-digit security PIN. Yikes.
But here's the twist in the story, and this is so important. The students tried all the classic JWT attacks. They tried to forge a new token. They tried to trick the server by changing the algorithm in the header to none to bypass the signature. And you know what? All of those attacks failed. The signature itself, that cryptographic lock on the passport, it was perfectly secure. The problem wasn't the lock. The problem was that the whole passport was left lying on the coffee table.
This whole investigation is just a masterclass in digital security. It teaches us some really powerful lessons that go way beyond just this one app.
It shows that real security, well, it's about a lot more than just having a strong lock.
So the real vulnerability here was where the token was stored. The COVID Pass app used local storage, which is super vulnerable to a common attack called cross-site scripting, or XSS. A much better way to do it, which the students actually saw in another MIT app, is to store the token in HTTPS-protected cookies. That makes it way harder for malicious code to just snatch it. But even that isn't a perfect solution. If you don't clear those cookies when you log out, they could still be exposed.
Okay, so let's boil this all down. What are the big takeaways? First, store these tokens securely. Just don't use local storage. Keep them in memory, or at the very least, session storage, which wipes itself clean when you close the tab. Second, be a minimalist. Only put the absolute essential data in the payload, never sensitive stuff like a permanent PIN. Third, if you absolutely have to include sensitive data, then encrypt the entire JWT, not just the signature. Add that extra layer of armor. And finally, make them expire quickly. The COVID Pass token expired in an hour, which isn't terrible, but for really important stuff, you might want it to expire in just a few minutes. That shrinks the window an attacker has to do any damage.
Every single day, your entire online life, your banking, your social media, your email is being protected by hundreds and hundreds of these little digital passports. The story of the MIT COVID Pass is such a powerful reminder that the line between secure and insecure isn't always some dramatic movie-style hack. Sometimes it's just a simple design choice made by a developer. Which really leaves us all with a pretty important question to think about. When it comes to our personal data, is good enough security ever really good enough?